Hello guys, welcome back to ChemOrgChem. Today we are launching a new series that is known as JEE Chemistry Insight, where we are focusing on JEE previous year chemistry exam papers. If you are new here, don't forget to subscribe. Let's see what's today's problem. So this is the problem from JEE 2007. So based on this problem, the species having bond order different from that in CO is. So here you see there are four options. Let's figure out together which one is the correct option for this question. Before moving to the option, we should know the what is mean bond order. So bond order definition is the number of bonds formed between the two bonded atoms in a molecule is called the bond order. For example, now you take the hydrogen molecule. So now you see only the one bond present in between this hydrogen molecule. Therefore, their bond order is 1. There are two ways we can calculate the bond order. The first method, if you know the Lewis structure, so you can easily calculate the bond order. The second method from molecular orbital theory. From molecular orbital theory, we have a formula. We can calculate the bond order of a given molecule. So now you see bond order means NP minus Na by 2. So here Np means total number of electrons present in the bonding molecular orbitals. Na means total number of electrons present in the antibonding molecular orbitals. The bond order is most important one. From bond order, we can calculate the number of bond properties. For example, bond order inversely proportional to 1 by bond length, and similarly bond order directly proportional to bond energy, bond enthalpy and stability. Okay, let's calculate the bond order of carbon monoxide by using this formula. So first you should write it down the electronic configuration of carbon atom. So which is 1s2, 2s2, 2p2. So next you should write it down the electronic configuration of oxygen atom. So which is 1s2, 2s2, 2p4. So next we need to write it down the electronic configuration of carbon monoxide molecule. So according to the molecular orbital theory, the atomic orbitals of carbon and atomic orbitals of oxygen both are combined to form the molecular orbitals. So in that molecular orbitals, electrons are placed in the appropriate levels. So which is we already know that. So based on that, we can write the electronic configuration of carbon monoxide molecule. So now you see sigma 1s2, sigma star 1s2, sigma 2s2, and sigma star 2s2, pi 2py2, pi 2pz2, sigma 2px2. If anyone find it difficult to understand this electronic configuration of carbon monoxide, you just see this molecular orbital diagram. So here due to the lower energy levels, so I omitted 1s orbitals in this diagram. I directly started from the 2s orbitals. So now you see this side is atomic orbitals of carbon and this side is atomic orbitals of oxygen. So now you see atomic orbitals of carbon. So 2s orbital holding 2 electrons and here oxygen 2s orbital holding 2 electrons. Now you see this 2s orbital both are combined to each other to form the two molecular orbitals. So one is sigma 2s, another one is sigma star 2s. So this one is a bonding molecular orbitals, this one is anti-bonding molecular orbitals. Similarly, here you see p orbitals, carbon p orbitals holding 2 electrons and oxygen p orbitals holding 4 electrons. So when it combines with these two p orbitals, which generates the 6 number of molecular orbitals such as pi 2py, pi 2pz, sigma 2px, pi star 2py, pi star 2pz, and sigma star 2px. In all these cases, the bonding molecular orbitals has lowest energy when compared to the antibonding molecular orbitals. Okay, now it comes to the electronic configuration of carbon monoxide molecule. So I already said that 1s orbital has lowest energy levels, so which is filled like our 2s orbital. So therefore we can write like this sigma 1s2, sigma star 1s2. And now you come to our 2s orbital case. So here you see sigma 2s holding 2 electrons and sigma star 2s. So this one is a anti-bonding molecular orbital holding 2 electrons and pi 2py 2 electrons, pi 2pz 2 electrons and sigma 2px 2 electrons. So now you apply our bond order formula Np minus Na by 2. So B means electrons having bonding molecular orbitals. So now you see 2, here 4 and 6, 8 and 10, total 10 electrons. So now you see anti-bonding molecular orbitals. So here 2 electrons and here 2 electrons. So total 4, 10 minus 4 by 2, which results that 3. So the bond order of carbon monoxide molecule is 3. So now you see the calculation of bond order is one of the tedious process, and you should know the electronic configuration of molecules, as well as sometimes you required to cross check their electronic configuration with molecular orbital diagram. So which is really a time consuming process. So we have here one trick. So if you memorize two diagrams, which is really simple to calculate the bond order of a given molecule within 1 or 2 minutes. So let's moving on our trick. So in this trick, you should know the total number of electrons. So first in a given molecule, you just calculate the total number of electrons, then compare with these two diagrams, you can easily find out the bond order of a given molecule. So in the first diagram, you should write it down or you should draw the W shape and put it the cross lines. So now you start the numbering from this end. So this end will get 0 and this point will get 1 and this end will get 2 and here 3, 4, 5, 6, 7, 8. So this each number indicates the total number of electrons in a given molecule. For example, in a given molecule, total number of electrons falls 0 or 4 or 8. Their bond order should be 0. In case of in a given molecule, total number of electrons falls in this range like 1, 3, 5 or 7. Their bond order should be 0.5. In case of 2 or 6, their bond order should be 1.0. So based on this diagram, is only applicable for in a given molecule having the total number of electrons 0 to 8 in this range. So next moving on our second diagram. So you just draw one triangle and put it the cross line, 5 cross lines. So now you start the numbering from this end. So here you see in this diagram we ended up with 8. So you should start with 8 here. So 8, 9, 10, 11, 12, 13 and finally this end will get 14 and now you come down here 15, 16, 17, 18, 19. So this one is here 20. Just like our previous diagram, these all the numbers indicates that the total number of electrons in a given molecule. For example, in a given molecule, total number of electron is 14, their bond order should be 3. So in a given molecule, their total number of electrons falls 13 or 15, their bond order should be 2.5. And similarly, 12 and 16, so their bond order 2.0. So 11 or 17, their bond order 1.5, 10 or 18, their bond order 1.0, 9 or 19, their bond order 0.5, 8 or 20, their bond order 0. So now you see, so from 3, so each level decreases 0.5, which it finally reach 8, 0 bond order. So based on these two diagrams, we can easily calculate the bond order in a given molecule within 1 or 2 minutes. So you need to memorize these two diagrams in order to effectively calculate the bond order of in a given molecule. So even though there are two demerits in this method, this diagram is only useful for in a given molecule falls the total number of electrons in this range 0 to 20. So otherwise it's not useful. A second demerit is in a given molecule, it generates the resonating structure. So at the time, these two diagrams is not useful. Let's calculate the bond order of carbon monoxide. So you should write it down the electronic configuration of carbon atom and oxygen atom. So now you calculate the total number of electrons, so which is 14. So 14 means you should use this second diagram. Here you see 14 total number of electrons, which means that bond order is 3. So their bond order is 3. Now you compare the our previous slide. So where we get the carbon monoxide bond order from molecular orbital theory, which also produce 3, and this method also produce 3, but this method is most fastest method to calculate the bond order. So let's see one by one each option. So now you see the first option. So NO minus is given. So you should write it down the electronic configuration of nitrogen atom and electronic configuration of oxygen atom. So now you add all the electrons. So total number of electron is 15. So here NO minus. So minus means that you should add one electron. So total number of electron is 16. So now you come to see this diagram. So here you see 16 total number of electron. So their bond order should be 2. So next moving on our option B. So here NO plus. So just like that, you just write it down the electronic configuration of nitrogen atom and electronic configuration of oxygen atom. Now you calculate the total number of electrons, and here you see now you see NO positive, therefore you should minus the 1 electron, so resulting that which produce 14 electrons. So 14 electrons means their bond order is 3. So let's moving on our third option. So Cn minus, you just write it down the electronic configuration of carbon. So 1s to 2p2 and electronic configuration of nitrogen atom 1s to 2p3. Now you calculate the total number of electrons 2, 4, 6, 8, 10 and 13. So here Cn minus, so you should add one of the electrons. So 13 plus 1 equal to 14. So 14 electrons means bond order is 3. So next moving on our final option, nitrogen. So N2, so write it down the electronic configuration of nitrogen atom 1s to 2p3 and calculate the total number of electron is 14. Now you see 3 plus 2, 5 plus 2, 7. So here 2 nitrogen, so 2 into 7, so 14 total number of electrons. So bond order is 3. So now you see except option A, option B, C, D produce bond order is 3, which is equal to the bond order of carbon monoxide. So based on our discussion, among the 4 options, the correct option for this question is answer A. That's it for today's problem. Today we have seen that how we can calculate the bond order of in a given molecule by using formula, as well as we discussed the simple trick to calculate the bond order of given molecule in a within 1 or 2 minutes. I hope most of them understand this bond order calculation. If you enjoyed this video, just give it a thumbs up and share it with your friends. Don't forget to subscribe and hit the bell icon for notification. And finally, thanks for watching. Bye bye.